very much. Welcome, everyone. Thank you so much for the invitation to come and talk to you all today about some of the research that my team does at NUS, also focused on net zero energy buildings, which is the focus of the workshop today. Of course, I'm going to introduce our flagship net zero energy building called SDE4, but I'll also, since I'm assuming a lot of you are all sort of very energy-focused professionals and researchers, I want to take you on a little bit of a tangent focused on the human side of things, because, of course, there we go. Of course, buildings are meant to help people. People use them to live, work, and play. So we'll focus on that in my keynote. First off, if you're not familiar, I'm from the Department of the Built Environment. We are a kind of sister department to the Department of Architecture. We focus on a lot of the engineering and technical aspects of the built environment, from project management to engineering to even law and budgeting and management. My specific team, we call ourselves the Building and Urban Data Science Lab. So we are a very mixed team of professionals from, of course, engineering and architecture, but also quite a few of the members have backgrounds in data science and computer science, which you'll see really drives into the type of research that we do. For those of you out there that are interested in data science, my team hosts an open online course on the edX platform called Data Science for Construction, Architecture, and Engineering. So we're trying to teach professionals in the built environment basic coding skills to help them analyze data sets from this environment. So check that out if you're interested. But today I'm here to talk about this building. This is called the SDE4 building. This is a net zero energy building at NUS. It's really our flagship building with respect to not just net zero, but also wellness and other aspects, which I'll talk about in a second. It's a beautiful building. Please check it out if you have some time. Those of you that are visiting Singapore, I highly encourage you to just stop by if you'd like to. And those of you in Singapore, if you haven't had a chance to visit, please do. This building is, the vision of this building is not just net zero and high performance, which you're going to hear a lot today about net zero, I'm sure, how to achieve net zero, it's quite difficult in a lot of situations. You have an energy budget that you have to produce as much energy as you consume. But you can't, we could make net zero buildings. Actually, it could be quite easy. We just don't air condition or light or provide any services to the occupants, right? We can't do that, and especially in the climate like Singapore. We need cooler and more comfortable spaces for people to do knowledge work, right? So high comfort net zero is the vision. And these first few slides are from Thomas Oyer, who's was part of the design team from a company called TransSolar. And this was their vision. I wasn't involved in the design. I'm more on the operations side, which you'll see in a second. And really one of the key aspects of this building is the cooling system, which doesn't seem like rocket science, does it? We're using air movement and elevated set point temperatures to create a space where we're balancing the comfort and the energy consumption side of things. So on the left, you see kind of the more conventional approach where you're pumping a glass box full of cold air, kind of the American style, let's say, of air conditioning. I can say that I'm American, so I can make fun of Americans, I guess. But it's more adapted to the comfort needs of the climate here. We don't need sealed boxes. It never gets cold in Singapore. We don't have heating systems. We can use, and in fact, all of you that live in Singapore probably do this in your homes. Sometimes you open the window and turn on a fan as opposed to turning on air conditioning. But we don't do that very often in commercial buildings. So that's what we wanted to try to change that paradigm with this building. As you can see, the building, there are certain parts of the building that do need full air conditioning. So you have things like computer labs and those type of spaces where you need full air conditioning. You have what's called hybrid spaces. About 26% of the spaces are this hybrid system of air movement and elevated air temperatures. And then a huge portion of the space is naturally ventilated. So any of the sort of social spaces where people are just hanging out or having a cup of coffee, spaces like transit spaces, hallways, and things like that are all naturally ventilated, because in this climate, it makes really no sense to enclose those spaces. It never gets cold here, right? It's a tropical place. So really thinking about the commercial building context in a very climate specific way is unfortunately kind of a new thing. In Singapore, we had air conditioning introduced to the country, which really changed the way things work. But now we're kind of going back to the basics of using all the tools and not just air conditioning. Those of you mechanical engineers in the room are going to love the next couple slides. I have a psychometric chart here. This is kind of the science behind this. This is the Center for the Built Environment has a tool where you can sort of map out comfort. Here you see this blue area in the psychometric chart. That's the comfort zone, right? And this red dot is where our conditions are in the SDE4 building. So you see the little sad face, little red sad face. That means that this theoretically, according to comfort models, people should be uncomfortable. But when you modify when you use more than one lever, if you're not just using aircon, you're using things like air movement, you're able to shift that comfort zone. So you're not asking people to change. I mean, you do ask people to change their expectations slightly, but theoretically, according to physiological models, they're comfortable because that whole comfort zone shifts because of the air movement, right? So you see the little green happy face instead. There's lots of other aspects of the building that I won't go into detail. Like I said, it's a well-certified building, so there's a lot of wellness-related aspects in terms of encouraging people to move, having lots of natural daylight. It's a very healthy building, in addition to being a net zero building. But I want to talk about the humans. Let's talk a little bit more about humans. So what makes humans satisfied in buildings? What do they want? And I bet if we took a poll right now and asked everyone exactly like how comfortable they are in terms of thermal comfort, we would achieve lots we'd have a diverse feedback. Some people I notice are wearing jackets. Some people have short sleeve, or not short sleeves, but sleeves rolled up. So we all have different expectations. We're all different essentially. So if we want to capture what makes people different, we could measure things. We could stuff a building full of sensors, which we do a little bit of. But there's too many things to measure, as you can see here, in terms, if we look beyond thermal comfort at light and noise, there's dozens, even hundreds of things that we would need to measure. So what we did in my team in the research that we're doing is we try to take a lesson from the digital, like the internet space, right? If you get on your phone and use social media or LinkedIn, something like LinkedIn is asking you all the time how you feel about what they're sort of showing you. And you indicate with a thumbs up or a little heart thing or whatever. They have like 6 different options now. I don't even know which one to choose half the time, but they're allowing you to sort of tag the data with how you feel. And so what we're trying to do is create that same type of tagging situation, at least in the research domain, by creating a like button for spaces. So those of you that fly in and out of Changi Airport, which everyone here probably has done, you know that when you come out of the washrooms, you can indicate like you're happy or whatever. So that's one example of that. But can we put sort of tablets on every wall in every space? Probably not. So we decided to build upon this, also this movement of wearable devices. There's a really good series of Economist articles from a year ago talking about the technology adoption of wearables, which you see on the left side. It's quite similar to what you see of a lot of other technologies that we all use. And then a lot of the other articles are about the impact that wearables are having. So it's not just encouraging you to take a few more steps, it's encouraging you to check your blood sugar if you have diabetes or if you have epilepsy, it's detecting that and calling help if you need it. So wearables are here to stay. They're going to become more and more a part of our lives, especially in terms of health. And so we decided to build upon that by creating a platform for interacting with occupants in the spatial context in buildings called the Cozy platform. We've developed it for 2 different platforms, Fitbit and Apple. It's an open source the part that we've created is open source so that anybody in the world can use it and create their own version of the app to collect information, both the physiological information from the watch itself, but also micro surveys, which I'll show in a second. So this is in collaboration with the Center for the Built Environment at UC Berkeley, which has a lab here called SymberBest. Here you can see this micro-survey component of it. You have 3 simple questions. We deploy the watch amongst our test participants, and they're given a watch and they're told just wear this and go about your day as you usually do. The watch will vibrate every so often, and when it vibrates, the participants are requested, they're not required, but they're requested to fill out this short survey indicating their preference, in this case related to thermal, visual, and noise-based comfort. So we're collecting dozens, almost in our studies, we collect 100 of these micro surveys per person in a diversity of spaces, indoors, outdoors, in office spaces, maybe even in their own home. So we're getting a better picture of what these people like, and we're creating models, machine learning models based on that. So coming back to the SDE4 building, we deployed this for the first time in 2019, just before the pandemic hit. We were able to create a really cool data set. Here you see a wireframe of the building, and each of these dots is a micro survey that was filled out by one of our participants. So you can see there's a lot of spatial diversity. We're getting a lot of data from a lot of different spaces. And this isn't just one person, this is about 30 people total that are creating this data set. And the yellow dots are people that are feeling comfortable. Blue dots mean that they prefer it cooler, which means they're feeling warm. And then red dots, believe it or not, are that people are preferring it warmer. So shocker, and sometimes in Singapore, in air-conditioned spaces, it's too cold, right? Which probably shouldn't happen in the tropics, but it does all the time. So this diverse data set allows us to create, and I'm not going to dive into a huge amount of detail, we create models to try to predict specific personal comfort. So a lot of our comfort models are generic. They're meant to be a one-size-fits-all model. Using this longitudinally intensive data, we can create personalized comfort models for people using the different features you see on the left. We can characterize people, but we can also characterize spaces in a better way. So the little red box shows this, using this type of methodology using watches gives us more information than we would get from other methods like email-based surveys and things like that. Here is kind of a demo. You've heard of the concept of digital twins. So we use this data also to understand how the environment around people works. So here you see an actual digital twin. You see in the middle of the bottom, one of our researchers walking through this SDE4 building. And as he walks through the building, we're detecting where he is. We're detecting what he's near. So we know he's near fans and diffusers and different types of objects. And then on the right, you see what's called a graph model, which is in data science is used to understand how things relate to each other. So we utilize the data that we collect from the occupants, but we also try to converge it with spatial data from the built environment context. And if you're interested, there's a lot of academic papers we have about how we converge these data sources, with the end goal being to better characterize people's comfort without having to deploy tons and tons of sensors. We can actually use BIM models and personal data collected. Thermal comfort is not the only thing that we care about. In fact, it's not even the most important thing, in my opinion, and especially in offices. There's also people's movement, getting more exercise. The middle one I think is the most interesting, noise, distraction, and privacy. This is becoming really a big thing now with people having the decision whether they work from the office or work from home. So when they do go into the office, maybe they need a quiet space, maybe they don't. And then of course, infection risk perception. So how safe do people feel? So we've also created micro survey flows related to these 3 areas. We're also working on micro survey flows related to human interaction, or what we call spontaneous interaction. So do people, when they do go to the office, are they meeting their colleagues in collaborative ways? Another cool thing that we're now just doing an experiment on is something called just-in-time adaptive interventions. So if anybody here has ever worn a smartwatch, you know that they like to bug you sometimes. If you don't turn off the feature, it'll bug you to stand up or take more steps. My Apple Watch always tells me to like do a breathing exercise. I think it knows I'm a professor and I'm stressed out all the time, I guess. So these are called JITIs, or just-in-time adaptive interventions. These are messages that help someone understand how they can make a change in their behavior that will help them. So we want to try that in the built environment context. So you can imagine, and the next slide I think kind of shows that framework that we're deploying right now. You see in the micro surveys on sort of the left, you see this thing called an intervention prediction model, and then on the bottom, in the right side, you see these little messages that we're testing, whether we can encourage people, for example, if they're thermally uncomfortable and they don't need to be in that space, they can choose to move spaces to another space. If there's noise problems, distraction problems, maybe they should put headphones in to help them. So empowering people to make decisions in the net zero building, net zero energy context, you can imagine this is related to turning off lights or fans, enabling power saving features on their computers. So you can kind of help change people's behavior so that the behavior of the occupants can work in tandem with the control systems that we're implementing in buildings, so kind of hand in hand. And this study we just deployed a few months ago, and we're looking at it from the whole, island-wide, not just any one space, but island-wide. So this is kind of into the scalability aspect. So understanding people in different spaces across Singapore, whether it's shopping malls or offices or their homes, we're collecting that data and we're understanding how to help influence an occupant throughout their course of their day, of their whole life cycle, I guess, or day cycle, I guess you call it. All of this research has provided a foundation for various collaborations that we've undertaken. We work closely with a PI, Adrian Chong, who's a professor at NUS, who does a lot of what's called mixed mode ventilation research. So he's diving even deeper into the net zero energy style system. He's starting to use the Cozy platform, and we're collaborating heavily to understand, for example, we're probably never going to have automated windows, I think, but we can nudge people to open the window, perhaps using something like Cozy when it's nice outside. We're working with Professor Stefano Scavan from UC Berkeley. There's a lab here in Singapore called the Simberbest Lab. So we're collaborating with him on more advanced thermal comfort models. We also work with a larger team led by Dr. Philip Bijecki. He's a geospatial expert, GIS expert, and he is working on the spatial context of cities. He's an expert in characterizing how cities work at the spatial level. We're taking our data sets and merging them into these spatial models to achieve these true digital twin kind of techniques and understanding the capabilities. A lot of people think digital twins are just maybe good for controlling, automation systems, but we think that they're also a tool for interacting with occupants and humans in the built environment. You can see a little graphic of a study that his group did using somebody walking around outdoor spaces and understanding their thermal comfort needs. Of course, a very famous professor, Prof. Wong Nye Kien, who's based at NUS, who does a lot of urban heat island research. So this is really, we're working, collaborating with him, looking at the urban scale. We're focused on the NUS campus and how to make the campus cooler through various interventions like vegetation and low albedo surfaces and things like that. So related to the net zero paradigm, but at the campus scale. And then I think last but not least, there's ETH Zurich is a Swiss university. It's quite famous. They have a lab here in Singapore called the Future Resilient Systems Lab. And we're working with a PI from the NUS side for this project, Rudy Staus, on urban scale flex-based working. So like I said before, it's not just a situation where I go into the office at 9 and go home at 5 or 6 every single day. I have choices. I can go into the office, I can work from home, I can go to a cafe. We all know how to work in that flexible paradigm. So what is the impact of that on buildings, right? Do we have empty buildings sitting around everywhere? I hope not, right? That's a waste of energy. So how does that new paradigm impact the urban setting, which is what we're looking at? And we'd love to work with everybody. This is an open source project, so we talk to a lot of entities around the world. Here you see a map of some of the entities we've talked to. You can see Kajima, one of the entities that's represented here today, we work with them on projects here in Singapore. It's open source, so anybody can use it. We're trying to expand this. We think that in a few years from now, we could have data sets from across the world that we are able to converge and understand how they can be used, of course. With that, I'd like to acknowledge all the people that helped. Obviously, all this work is not just me doing it. There's lots of other people involved. If you'd like to download a PDF of this slide deck, you can scan this QR code and you'll have the slide deck, because there's lots of little links that you can click on to follow and get more information. So thank you very much.